So we're using zebrafish as a model system to understand how patterns of neural activity develop in early life. And the great thing about the zebrafish is that young zebrafish is transparent, and we can insert a gene which means that neurons glow when they're active. So we can convert the electrical activity of neurons into an optical signal that we can record under a microscope. So we take a young fish. When I say young, I mean just a few days since it was a single cell. We embed it in a gel under a microscope, and then we can image the activity of every neuron in the brain as it sits there thinking its fishy thoughts. So what we want to do is two things. Firstly, understand how normal brain development occurs. So understand how a nervous system becomes wired up during development, how patterns of activity emerge which appropriately represent and process information. So I think that, that's important for understanding obviously our biology. It's also important for developing new forms of artificial intelligence. So all artificial intelligence at the moment, the hardware is designed by humans and put together by humans. But in the long term, one can imagine an artificial intelligence that grows itself more organically, perhaps inspired by the kinds of things we're discovering about how real nervous systems are built. So besides understanding normal development, we also want to understand what happens in neurodevelopmental disorders. So a lot of human neurological disorders are actually developmental in origin. So they're because the brain didn't become wired up properly, for instance, during development. And so we can study that in zebrafish by looking at zebrafish which have genes mutated to mimic certain human neurodevelopmental disorders, and then look at how the brains of those fish develop compared to the brains of the normal fish. And that allows us to see what's happening early on in a way that's just not possible in humans or even in mice, because we can access the zebrafish brain much earlier in development than in mammalian systems.